How do we determine the domain of a function defined by an equation? Well, two questions. Ask yourself the right question. What works or what doesn't work? Now, if things have square roots, it's easier to ask the question what works, because we know that it has to be positive or zero. So therefore, if we just say everything under the radical has to be bigger than or equal to 0, all I have to do then is solve for x, and that gives me the domain. Now, if it looks like a fraction, then we know what doesn't work. What doesn't work is the denominator being equal to 0. So if I solve the denominator set equal to 0 and solve for it, x in that equation, then I get what doesn't work, and so then my domain is everything but that. Why is the domain of x cubed and x squared of x, or cube root of x and squared of x different? Well, I think if you just go back to square and cube, it's pretty easy to see. Notice that when you square something, you never get negative. So if square root acts like the opposite, reverses it, we're going to call that the inverse when we get to it. And there's a little bit more to that. But notice that you can't plug in a negative and get something that's positive, right? When you take the square root of a negative, you're never going to get something that's going to give you an answer. Where the cubed root, that's always the case. No matter what you plug in, there's something that's going to come out. So we can see that what we learned in the last section about one-to-one is going to play a big part of what we mean by having an inverse function. Now, kind of a rule of thumb, and it's real easy, is if it's an odd root, you can plug anything into it. So like you see the 3 there, that's the right, you see the 3 there, that's odd, so we know that all real numbers will work. And if it's even, so like this is supposed to be a 2, right, we don't write it because we always assume that's true. But if there's 4, 6, then we know that this thing would have to be just positive or 0. When do we use round and square brackets? The round parentheses we use when we don't include the endpoint, square brackets when we do include the endpoint, and that's really all it is. And if we're talking about infinity, then we always, right, if you're ever talking about infinity where you're greater than 0, you're always round brackets, because it always goes on and on. Infinity is not a number, it's a concept. The idea is you're always getting something bigger, or negative infinity, always something smaller. How do you graph a piecewise function? Well, one way to do it, and what I did kind of here, is I graphed the two functions, x squared and 1. X squared is in purple, and y equals 1 is the red line. Now, what piecewise means is that over different parts of the domain, different functions are defined. So if you look at f of x up here, right, this says if it's less than 1, it's x squared, and if it's greater than or equal to 1, it's 1. So in other words, when I'm all from negative infinity up to 1, I follow the purple equation up to here, and then once I get to 1, I switch this one and I follow 1. So you get a graph that looks like this. And that's what we mean by a piecewise defined function. Different function defined over different pieces of the domain. All right, let's find some domains and ranges. Or domains anyway. So we have this one right here, 3 minus the square root of x minus 2. Now this doesn't really do anything to the domain. The whole piece of the domain that's going to restrict is what goes here underneath the radical. And so since it's under the radical, we can ask the question, what works? Well, we know that anything under a square root has to be bigger than or equal to 0. So now we can just solve for this. Subtract that over. Divide by the negative 2, which of course means that I have to flip this around. This gives me x is less than or equal to 3. And so there's the domain. As set notation, we just throw the jewelry on and get something that looks like this, right? For interval notation, we're going to have closed brackets because of the equal sign, 3, and it goes, oops, sorry, wrong direction. So we have negative infinity up to 3 because that's the largest with a closed bracket, like that. So now if we try this one, let's do f of x is equal to 9 over x minus 6. Now this looks more like a fraction. So let's say we know that the denominator is not 0. So find where it is 0 and then take everything else. So this is add 6 over, we get 6. So this is our domain. If we write a set notation, would be everything but that, so everything that's not 6. Now as interval notation, it would be everything except 6. And this symbol, the cup, means union or. Okay, or. This, it's in here or it's in there. And one more, just because I thought it was kind of interesting. Our function looks like x squared plus 4. Now the thing we know is that when you square something, it's always bigger than or equal to 0 because it becomes positive. So if I add 4 to both sides, then this is bigger than 4. Well, I never have to worry about a square root because this number is always 4 or bigger, so it's always positive. So that tells me that my domain is all real numbers, right? All real numbers. All right, so let's look at these two equations, figure out the domain and the range. Well, because this is colored in, we're going to assume the domain goes from -5 inclusive all the way up to 3, and since that's open, not inclusive. So square brackets on the -5, round parentheses on the 3. Now the range, because it starts at 0, that would be a closed bracket 0, and it goes up to 2, but included not because of this one, but because of that one, the left side. So that would be 0 to 2 would be the domain. Now this is kind of the same thing here. Domain goes from -3 inclusive, so square brackets, to 2 round parentheses because that's open, not included. Now the range, the small number, is going to be -5 because that's colored in up to 4. This doesn't matter because it's getting overlapped. So really just want to go to this largest value here, 4. So it's going to be square brackets -5, square brackets 4. All right, see, let's try another. Let's go to this one right here. So you'll notice that this one is open brackets on, kind of guess at -2.5 between the two of them, right? And round, and the round bracket. Now it goes all the way up. Now because there's an arrow there, it means it goes on forever. So it's going to be -2 off to infinity. That'll be our domain. Our range has the smallest value of -4. They're the same, but see, it goes off forever, so it's going to be -4 to infinity.